rate constant times NO2 negative.
So which question are you doing? Okay.
Third one, NO2 negative, I negative. And then we have H plus squared, right? This is the rate equation. And they have asked, the first thing is that what will happen if the concentration of I negative is halved, right? So for this, the rate will become R by 2. That is correct. Second one is because I negative is what? It is having power 1. So whatever is happening with I, the same thing will happen with rate, right? Because the rate is directly proportional to the concentration of only I. Then in the next case, we have H plus is doubled, right? H plus is doubled. Now you can see that the rate is directly proportional to the square of the concentration. So if we are doubling this H plus, that means rate will be 2 square, right? That means it will be 4 times. So 4R ho jayega. Then we have the third one, that is what we are doing. We are tripling the concentration of triple each species, right? We are tripling the concentration of NO2 negative, I negative, and H plus. So rate is what? Rate is proportional to the concentration of NO2 negative into I negative into H plus square. Now what we are doing? So rate will be what? Rate will be proportional to N2's tripled 3 times into I is also tripled 3 times into H is also tripled, and you have to do square also. So rate will be 3 times. This is what 3 into 3, 3 to the 4. So it will be equal to how much? 3 3s are 9. 3 3s are 9. It will be equal to 81. So it will be 81 R. You got this last one? Yes or no? Please tell me, guys. फातिमा आया आपको?
Yes, sir.
Okay. Write this down. किसी और ने किया है असाइनमेंट और किसी को कुछ डाउट है तो फिर बताइए प्लीज. Fatima, I will check it and I will tell you if you have to make any other corrections now. Okay, Fatima?
Yes, sir.
Okay, fine. Achha. One more thing is there. This is for Ahmed and Wafia especially. Okay, Fatima is not here. Okay. Ahmed and Wafia, actually you both were not present in one of the classes, and in that class I asked Sarah, Fatima, and Mariam. Mariam is not here. Fatima to hai. Mariam is not here. That I will send them one question every day. Okay. One numerical every day. Achha, every day का मतलब है there will be some days in which I will not send, because for example जैसे आज you had a test for solution chapter, so I will obviously not send today. Then if you already have some kind of assignment, for example on Tuesday I gave you assignment, right? And Monday I gave you assignment, then you have Tuesday, and then you have Wednesday. So I will not give you the questions on Monday, Tuesday, and Wednesday. Okay, I will not give you in these days. Why? Because Monday you should revise on your own for the chemical kinetics chapter, and then complete the assignment that was given on Wednesday. Then on Tuesday also you should do the assignment that was given on Monday, and then Wednesday you should prepare for the today's class, that means chemical kinetics class. So Monday, Tuesday, Wednesday I will not give you, but I will give you the assignment on Thursday, Friday, Saturday, and Sunday. So I will give you one numerical on WhatsApp. Okay, so I will send you over WhatsApp one question, one photo. Then you have to send me the answer on the same day. Okay, Ahmed and Wafia. Okay, fine. And this numerical will be from solution chapter. Okay, it will be from the solution chapter. And electrochemistry. Okay, the previous chapters. जो चैप्टर चल रहा है ना केमिकल काइनेटिक्स, जब खत्म हो जाएगा देन व्हाट्सएप में आपको केमिकल काइनेटिक्स के सवाल मिलते रहेंगे, असाइनमेंट्स आपको दूसरे चैप्टर का मिलता रहेगा। ओके, सो इन दैट केस यू विल बी डूइंग द असाइनमेंट्स आल्सो, और फिर रिवाइज भी करते रहिएगा आप साथ साथ में। अच्छा, किसी दिन अगर हम नहीं भेजेंगे ना, तो प्लीज आप ना एक बार कोई भी हमको मैसेज कर दीजिएगा आप लोग में से, ठीक है सर आपने सवाल नहीं भेजा आज। ओके फाइन, नाउ लेट अस डू समथिंग and write about the mechanism of a reaction. In the last class, we said that we can determine the rate law and we can determine the order of a reaction by three methods. The first method was using the units. The second method was the experimental results. And we had mechanism as the last. So please write mechanism of a reaction. Write the topic. Mechanism of reaction. Right here. Each chemical reaction is completed in either one step, or more than one step. Or more than one step. On this criteria, the chemical reactions are divided into the chemical reactions are divided into two types. Number one is elementary reactions. Number two is complex reactions. Elementary reactions and complex reaction. After you're done writing, you will write the topic elementary reactions. Now right here, the reaction which is completed in single step is called elementary reaction. It's called elementary reaction. Okay. Now, please write a note. The order of an elementary reaction is equal to the sum of stoichiometric coefficients of the balanced chemical reactions reaction. Okay, so please remember this point, very important. What is in elementary reaction? If it is happening in one step, then whatever the coefficients are there of stoichiometry, that will be what? That will be the order of reaction. That will be the order of reaction. So for example, if you have something like this, let us say a general reaction in which AA plus BB is giving you CC and DD. Now in this case, I can directly write the rate of reaction. I will write R is equal to, okay, R is equal to K into concentration of A to the power A multiplied by concentration of B to the power B. And the order of reaction is equal to A plus B. And now you may see that is different from what we have done. Now, please remember that mechanism is also determined experimentally only. Okay, mechanism is determined experimentally. Now, once we have determined the mechanism of a reaction, we can theoretically say that the order of reaction will be equal to its stoichiometric coefficient. Please write this down. Mariam, take a screenshot. How are you, Mariam?
Much better, sir.
Much better. Okay, fine. Did you watch the lecture, by the way?
Yes, sir. I watched.
Any doubt in that?
No, sir. Not yet.
Not yet. Okay, fine. एक बार अच्छा, did you get the assignment, Mariam?
Yes, sir.
So try the assignment. If you have any doubt, then please message me on WhatsApp only. Okay, all of you. If you have any doubt in assignments, you will all message me. Okay, all of you wrote yes or no, please tell me.
Yes, sir.
Okay. Now, when a reaction happens in a single step, now let me explain this, why it is equal to the order of reaction. When it is happening in a single step, that means this chemical reaction, this balanced reaction, what it is doing, it is representing the actual situation. That means if I have, let us say, A plus 2B, then there will be one molecule of A like this, and there will be some 2 molecules of B which will be coming, and they will be joining the A like this. Okay, so it is representing, when it is happening in elementary, that means one step, then that balanced chemical reaction, it is what? It is representing the actual situation. And that is why if it is representing the actual situation, that means for each 2A, we require 2 molecules of B for each and every reaction. And also it is not a complex reaction in which it is happening in steps. Okay, it is happening in one single step. So for each reaction, I need 1A and 2B. Okay, so for each reaction to complete. Now, if I look at the complex reaction, so please write here. Right, for complex, then you will understand the elementary much better. Right, complex reaction. Please write the reaction which is completed. In more than one step is called complex reaction. Now write a note. Every step of a complex reaction does not proceed with same rate. Does not proceed with same rate. Okay. Now, let me ask you one very common thing. Think of a situation. You have to dry. You have washed your shirt, your t-shirt, and your jeans also. Okay. Now, in order to dry, please see here. In order to dry, shirt takes, let us say, 10 minutes. T-shirt takes 5 minutes. And jeans takes 15 minutes. Please answer me in chat. What will be the total time taken to dry all of these items? What will be the total time taken to dry all of these items? Please tell me in chat. If I have to dry these things, these three things, shirt, t-shirt, and jeans, how much time will be taken? What happened, guys? Please answer fast. Only Sarah and Ahmed have answered. Okay, Wafia. नहीं तो आप किसको भेज रही हैं? आप सालिम को भेजिएगा ना, आप लर्निवियो को भेज रही होंगी. हाँ फातिमा.
Sorry.
Okay, fine. That means there are people who have answered 30 minutes. है ना? So you are saying that when you have dried the shirt, so the shirt will be waiting, है ना? And the t-shirt will be waiting. It will ask the shirt, "आप सूख गए पूरा?" Then it will start drying itself. Then when the t-shirt is completely dried, then the jeans will ask t-shirt that, "Okay, are you dried completely?" Then the t-shirt will say yes. Then the jeans will start drying. ऐसे होगा क्या? हाँ? Tell me. All of them will dry at the same time, na? So the time taken will be 15 minutes. Yes or no? The total time taken to dry all of these things will be what? 15 minutes. Correct? Yes? What happened? Mariam? Wafia? Got it, Wafia?
Yes, sir.
Okay, fine. Great. That means the rate means the time that is determined. So the time determining step will be the slowest step. So what is determining the speed of drying clothes? The cloth item which takes the longest time, that is determining how fast the clothes are going to get dried. That is why here also there will be different steps, and the slowest step of the complex reaction will determine the rate of reaction. So please write the next point. The slowest step of the complex reaction determines the rate of reaction. Determines the rate of reaction and is called, and that step is called rate determining step, RDS. What was the full form of RDS in 9th standard? What was the full form of 9th 10th standard में क्या था full form RDS का? And I think still today. What was the full form of RDS in 9th 10th standard? 9th 10th में तो सबने किया होगा. How many of you have done this book, R.D. Sharma? No one. Sara, Mariam, Fatima, Ahmed, Wafia, R.D. Sharma. Have you heard of R.D. Sharma?
Sir, I've heard of him, but I haven't done anything.
Okay. Fatima?
Same, I heard of it, but I didn't do it.
करना चाहिए था. Done, guys? Yes or no? Please tell me. Wrote both the points. Now, please write one more thing. Each step is an elementary step. Okay. Hence, the coefficients, stoichiometric coefficients of RDS gives the order of reaction. Should I move forward? Yes or no? Please tell me.
Sir, 1 second, sir.
Okay. लिखिए लिखिए जल्दी लिखिए.
Okay, sir.
Now, question. Determine the order of reaction and rate law expression from following mechanism. From following mechanism of. So we have a reaction in which nitrogen dioxide, it reacts with carbon monoxide and it gives nitrous oxide plus carbon dioxide. Now in mechanism, there are two steps. Step one is we have nitro NO2 and NO2, they react with each other and first of all they form NO plus NO3. Okay, NO plus NO3. Then next what happens here? Next what happens here is in step two. This is all question, okay? This is all question. Yeah, they are also giving you the mechanism. What do we get here? We get NO3, which reacts with CO. And what do they form? They form CO2 plus NO2. Now here this reaction is slow and this is fast. Now you tell me which step is the RDS, step one or step two? What is the genes here? What is the genes here? Tell me.
Step
One or two?
Step one.
Very good. This is my genes or the RDS. Okay, this is my RDS. Now we know that it is balanced also. So from here you can write this solution. Order of reaction is equal to sum of coefficient of RDS, right? So what is the coefficient here? 1 and 1, that is equal to 2. This will be the order of reaction. And the rate law will be equal to what? K into the concentration of NO2 into the concentration of NO2. That will give you K into NO2 square. Got it? Yes or no? Please tell me. All of you following me? Any problem in understanding this? How to solve this one? Please tell me. Yes, Fatima. I can't hear you.
No, it accidentally got unmuted.
Okay, okay. Done, guys? Yes or no? Please tell me.
Done, sir.
Okay. Right question. Again, determine order of reaction and rate law. So the reaction they have given here is 2NO plus F2. It forms 2NOF. Okay. The mechanism that they have given is, suppose you have here NO and it reacts with, first of all, F2. And it will give you NOF plus F free radical. Okay, this is slow. This is the first step. Step 2 is, we have here fluorine. It reacts with another molecule of NO and it gives NOF. Right? This is fast. Now tell me what is the order and the rate law. Tell me, what is the order of reaction? What is the genes here? Step 1 or step 2? What is genes here?
One.
Step 1 is my genes. So what is the sum of the stoichiometric coefficient of RDS? What is this? What is the stoichiometric coefficient of NO? क्या है? NO का stoichiometric coefficient क्या है? 1. And for F2 it is also
1.
1, right? So the order will be equal to 2. Okay, the order will be equal to 2. Just a second. Okay, so the order of reaction will be 2. Now you have to write the rate equation. So after K, what you are going to write? What is present here? NO
Sir,
and F.
plus NOF.
NO and F2. And now please remember, not 2NO. Okay, please remember this.
Yes, sir.
Okay.
So why did you write F, not F2?
हाँ नहीं वो मेरी गलती से. You're asking why? I will say गफलत में. My bad.
So,
हाँ.
so
Tell
they
me.
will give the steps and mechanism in the question itself.
Mechanism will be given. Okay. So there is this one type of question in which you are given the mechanism. You have to find the order and the rate. There will be another type of question that we'll see right now. Okay, we'll see right now. If the order of reaction is equal to 2 and this is the rate, they will ask you, they will give you this part here. And then they will ask you, propose a mechanism. propose mechanism for 2NO plus F2 giving 2NOF. So this is the part that is given. They have given you that rate is equal to K into NO. So when you have been given this part, then you will react this NO and this F2 first. So you'll write the step 1. That will be your slowest step because it is determining the rate. You'll write NO plus F2. It is going to give me NOF plus F. After that, you will write such slow. You'll write step 2. F plus NO is giving me NOF. Okay, so there are 2 types of question. We will do more of these type. Propose the mechanism now. Write this. Done, guys? Yes or no? Please tell me. Oh, done? Yes or no?
Done, sir.
आवाज नहीं आती है एकदम. Right, next question.
Sir,
बताइए
I
बताइए.
have one doubt, sir. Sir,
बोलिए. Yeah, tell me.
sir, if we are not like this, we already know because the past question, which is step 1 and step 2. Okay, but what if we write the step 2 as step 1 and step 1 as step 2?
Oh, you are saying that ये कैसे पता चला कि कौन सा step, मतलब कौन सा slow and कौन सा fast है, right?
No,
Basically.
sir. Like, how do we know that NO plus F2 is not step 2? But
नहीं, वो छोड़ दीजिए. You can write that as step 2 also. वो step 1 आप लिख सकते हैं उसको. लेकिन दूसरी चीज ये है, step 1 में you can only use the reactant, right? You will use either NO or F2. सही है? Step 1 में you cannot use fluorine ना.
oh yes, sir.
Are you getting my point? है ना? एक तो चीज ये. But मान लेते हैं ऐसा है कुछ कि you have 3 reactants, okay, and then you are confused कि step 1 step 2 कर सकते हैं. तो अगर उस तरह का कुछ केस है in which you are not using any of the product from the previous reaction, then you can vary the step number also, okay. But वो पता चल जाएगा आपको. करते हैं ना, अभी सवाल करते हैं, फिर धीरे धीरे आ जाएगा आपको. Okay, write a question. 2NO plus H2, rather 2H2. 2NO plus 2H2. It is going to give you N2 plus 2H2O. The rate law for this question is, the rate law for this reaction is R is equal to K into the square of NO and H2 only. They will ask you propose a mechanism. Okay. So Ahmed, since you asked it out, tell me what will be the step 1? What will be the step 1?
So step 1 will be 2NO plus
2NO plus
H2
H2
gives
एक तो H2O बन जाएगा, right?
yes sir.
Here you can see H2O. अब बचा क्या? N2 बच गया अब.
N2.
That is it ना?
Yes sir.
नहीं, यहाँ पे आपके पास H2O2 बनेगा. Okay, can you see that? You have 2 oxygens also. So the product that you can form here is H2O2 plus N2. Now in step 2, this will be your slow step. In step 2, what you are going to do? In step 2, we are going to react. N2 is already there in the product, so I will write H2O2 plus we have one remaining H2. This will react and it will form what? 2 molecules of H2O. Done all of you? Yes or no, please tell me. Done everyone?
Done, sir.
Okay, right, next. You have been given a reaction. 2N2O5 is giving you 4NO2 plus O2. The rate law is K into the concentration of N2O5 only once. 1N2O5. They're asking you propose the mechanism. Done. What will be the first step? The slowest step will be number 1. Step 1. See, the N2O5 will be there only, and it dissociates into 2. One is NO2 and the other is NO3. This is your slow step. Okay, this is my slow step. Now, further, what is going to happen? Further, you will have NO3 plus we have O2. It is going to form what? What is it going to form? We have NO3 and then we have O2 here, right? So first of all, it will form. No, sorry. O2 नहीं है हमारे पास. We have NO3 plus N2O5. So we have how many? 3 nitrogen. So 3 NO2 will be formed plus 6. Okay, we have here 8 and O2 will be formed. This will be fast. If they have to ask, they will ask from here only. They will not ask any other reactions. Okay. Important one is this one. This is more important, N2O5, and it's more important here. Done everyone? Yes or no? Please tell me.
Done, sir.
Right, next, molecularity of reaction. Right, next, it is defined as number of reactant molecule which must collide, number of reactant molecule which must collide simultaneously simultaneously in an elementary step. In an elementary step or reaction. Okay. So for example, we have H2 plus I2 giving me HI. Okay, so in this case, one molecule of H2 it should should collide with one molecule of I2, and it will give you what? It will give you HI. Two molecules of HI. That means your molecularity is equal to how much? One H2, it is attacking one I2. So molecularity will be 2. Okay, so I'll write some other reactions also. For example, if you have PCl5, okay, when we heat PCl5, it breaks into PCl3 and Cl2. So in this, how many reactants we are using? Tell me. How many reactants are we using in this second one? How many reactant molecules are there? Arey, what happened? No one is answering. How many reactant molecules are there in second case? Ahmed, Fatima, Mariam, Sara, Wafia. आप लोगों को आवाज नहीं जा रही है क्या? हाँ ना नहीं पता, कुछ तो बोलिए. Yes, Ahmed, tell me. How many molecules? Fatima, how many molecules? How many molecules are there in the reactant? It is defined as the number of reactant molecule which must collide to simultaneously in an elementary step. So when you have elementary step, here we had one H2 and one I2. They added up to 2. Here we have one PCl5. तो molecularity क्या होगा? 1 होगा. ध्यान दीजिए आप लोग please. Right next and tell me the molecularity. 2SO2 plus O2 is giving me 2SO3. What will be the molecularity?
So 3.
Very good. ठीक है. अब यहाँ पे आप बोलिएगा सर ये तो रिएक्शन के लिखने के ऊपर है ना. If you look at this reaction, I can write this reaction as SO2 plus half O2 is going to give me SO3. Yes or no? Both are same reactions, right? तो सर फिर आप बोलिएगा तो सर क्या molecularity यहाँ पे is the molecularity here 1 plus 1 by 2 will be equal to how much? 3 by 2. Is this the molecularity of the reaction? I will say no. I will say no. Why? Because I'm seeing number of reactant molecule. Na, number of reactant molecule, it should always be what? It should always be whole number. Half O2 तो collide ही नहीं कर सकता ना. Why? How will half of the oxygen molecule? Now we can say half moles of oxygen molecule, it is fine. But how can a half molecule oxygen can collide? वो तो exist भी नहीं करेगा. What is half molecule of oxygen? It is nothing, right? So when we write the chemical reaction, there are 3 levels actually. So we write it in the molecular level. If we write it in the molecular level, then we are talking about molecules. Now, when we write in the molecular level, it should not contain any fractions. So in this case, I will say that this is not right. And when you get any fraction like this, then the numerator here, it will be your molecularity. It will be your molecularity. Okay. If we get anything like this, for example, let us take this case here. So I can take half H2 plus half I2 is giving me what? It is giving me 2HI. So it is giving me HI only. It is giving me HI. So you'll say, sir, is the molecularity 1? We'll say no. The molecularity is not 1. Why? It is not 1 because how can half H2 molecule exist? Half H2 molecule cannot even exist. So you'll write and convert this all into what? Into the whole number. You'll write 1, 1, and 2. So write a note. Always write the reaction in such a way that coefficient of reactant molecules are whole number and not fractions. Shall you write this down fast? Let me know when you're done. Write remarks. Write remarks. Number 1. When molecularity is equal to 1, the reaction is called unimolecular. When it is 2, the reaction is called bimolecular. Okay, right, next. It is a theoretical concept. It is purely based on theory and associated with balanced chemical reaction and associated with balanced chemical reaction. Right, next. It can never be 0. Right, next. It does not determine the rate of reaction. The rate of reaction. Since rate of reaction is the experimental concept and this is the theoretical concept. That is why this theoretical concept cannot be used to calculate or determine the rate of reaction. Right, next. It is independent of reaction conditions such as temperature, pressure, etc. Now, last point. Molecularity can never be more than 3, as molecularity can never be more than 3 as the number of reactant molecule as the number of reactant molecule increases, its chance of effective collisions decreases. But I have been silent for how much time? Ahmed, Fatima, Mariam.
Since you started doing all of that.
Since I started drawing these things, okay, fine. I'll explain this. तो बोलना चाहिए ना, आप लोग क्या एकदम यहाँ पे नाटक देख रहे हैं क्या? See, when we have two molecules, then the point of contact is very large. They contact and they touch each other in a very large surface area. When it becomes 3, then the surface area, it decreases a bit. And in the fourth structure, you can see that two of the opposite, like diagonally opposite molecules, they are not even touching each other. That is why when we have 4 molecules, the collision is not effective and they don't react properly. So the molecularity, it can never be more than 3. It can never be more than 3. Now, then I said that there will be some complex cases that you can study later in the higher standard, that if you have 3 molecules like this, and then one molecule is coming from the above and it is reacting from above like this. Now all the 4 are touching each other. Now all the 4 are touching each other, and then this reaction can happen. But this you don't have to study, है ना? ये बाद में कभी पढ़ने को मौका मिलेगा तो पढ़िएगा, okay? But it is not there in your syllabus. So 2 is fine, 3 is fine, but 4 no. 2 is fine, 3 is fine, but 4 no. है ना? There are very rare cases when 4 things are fine. But generally 4 things are not fine in this whole world also. The lesser the better. 2 is the best. 2 is the best. 3 gets a bit complicated. 4 can happen, but it is very complicated. Anna, you can relate this to your real life also. Chaliye, done everyone? Yes or no? Please tell me.
Yes.
Okay. Right, next, types of order of reaction. So we will learn about the types of order of reaction. You start with the zero order reactions. So we are classifying the reactions. We are classifying the reaction on the basis of their order. On the basis of their order. So we will be studying only 2 that you have to study. Okay, you have to study the zero order reaction and you have to study the first order reaction. You have to study the first order reaction. Okay, there will be some examples also that we'll be discussing. We will also write the integrated form or the differential form. Then after that, we will be studying about the half-life period of both of these things. So we will study zero order and then we will study the first order reaction. We'll study the first order reaction. So write the topic now. Zero order reaction. Zero order reaction. What is zero order reaction? The reaction in which, please write with me, the reaction in which the rate is independent of concentration of reactant. Is called zero order reaction. So for zero order reaction, if I have, let us say, for example, A giving me product P, then the rate law will be R is equal to K into the concentration of A to the power 0, zero order. And this will become what? It will become R is equal to only the rate constant K. You have to remember this one. You have to remember what I have drawn inside the, this is for zero order reaction. Okay, so what is the rate of reaction equal to? Please write. kind of note. In zero order reactions, rate is always equal to the rate constant. Done, guys? Yes or no? Please tell me.
Yes.
Right, next. Expression for. So for all of these, we will be deriving the expression for the rate constant. Okay, we'll be deriving the expression for rate constant for all of these order of reactions and the different types of reaction. Okay, different types of reaction. So please write. Now, we have two different reactions. If I have, let us say, A giving me product P, then we have two different expressions. R is equal to the rate constant K into the concentration of A to the power 0. Okay, so this is something that you don't have to do any theory work. What you can do, if you know the rate constant and you know the initial concentration, so this here R will be equal to what? R will be equal to the rate constant K only. Right? So if you know the rate constant, you will know the rate of reaction. But we also know that rate of reaction is also equal to minus dA upon dt. Right? This is what? This is experimental rate. That means you have to perform an experiment in order to get the rate. This is experimental rate, and this is theoretical rate. But both of them will be equal. Okay, theoretical rate and experimental rate will be equal. So now what I can do, I can write a equation like this. I can write an equation like this in which I will equate minus the concentration of A, difference in concentration of A upon dt. It is equal to what? It is equal to K. Any problem till here? Please let me know now. Any problem till here?
So how did the experimental rate come?
Yeah, minus dA by dt.
Yeah,
In this expression you have not seen earlier.
I don't remember.
Rate is equal to minus the change of the concentration of reactant divided by the change in time.
Yeah.
For instantaneous, we write it minus dA upon dt. हाँ बताइए क्या दिक्कत होगी? Got it, Fatima?
Yes.
Okay. So this experimental rate has nothing to do with order and all. Okay, please remember this dA upon dt. It has nothing to do with order. What you will do, you will go take A and then you will start reacting, and then you will be seeing the change. Then you will see how much A has been consumed in a particular difference of time, in a particular interval of time. Then you will divide concentration of the reactant that has been consumed divided by time. Concentration of A that has been used divided by time, you will get the rate. It has nothing to do with the theoretical order of reaction or something like that. Okay. Now we have minus dA upon dt is equal to K. You will have to remember this is the next expression that you have to remember again for zero order reaction. Now what I am going to do, I'm going to do variable separation. Variable separation means I will have this minus, dA and equate this to, and I will equate this to K into dt. After done, what I am going to do, I'm going to integrate this. I'm going to integrate this. Integrating both sides. What I'm going to get, I'm going to get here integration of, I can take the minus away. dA is equal to, I can take the constant away, integration of dt. So what I'm going to get here, I'm going to get integration differentiation. They will cancel each other. I will be getting A, or rather minus A, because minus is there. minus a is equal to what? Minus a is equal to k, and from dt I will get only t. Please remember there will be a constant here also, right? Integration constant. So this is my expression that we have. This is my expression that we have. Now what I can do, I can rewrite this expression in such a way that this is your, first of all, expression that you have to remember. Another expression, okay, that you have to remember. You have not done anything, you have just integrated this equation here. Done yahan tak? All of you wrote this, yes or no? Please tell me. Expression of rate constant. All of you wrote this? हाँ या ना,
Yes,
जल्दी
sir.
बताइए. Yes,
Yes,
what
sir.
about others? Fatima, Mariam, Sara, Wafia, please
Yes.
speak something. हाँ,
Yes,
speak
sir.
something. ना रेजिस्टेंस लेके बैठते हैं आप लोग बिल्कुल शांत से ऐसे. Not good, हाँ, एकदम not good. Okay. Now let us look at this equation here, and let us determine what is this constant. Okay, let us determine what is this constant. You write here at time is equal to 0. At time is equal to 0. That means when we are starting the reaction. In that case, I will have. In that case, what will I have? What will I have here? I will have here minus a is equal to k into 0 plus the constant. Okay. Now k into 0 will be equal to 0. So this will be what? Minus a, which is equal to constant. Right. So the constant is concentration of a. Constant is concentration of a when time is equal to 0. That is initial concentration of A. And please don't write, please listen. Concentration is what? Is the concentration of A when time is equal to 0. That means it is what? It is the initial concentration. And we show the initial concentration as A naught. So we'll write constant is equal to minus A naught. All of you got this point? Yes or no? Please tell me.
Yes, sir.
Yes. Okay. Now what I can write? I can rewrite this equation. Now you'll plug in this constant here. Okay. So minus A minus the concentration of A is equal to KT into minus A naught. KT into minus A naught. Okay. KT into minus A naught. Now, when I will get this minus A naught this side, I will get A naught minus A is equal to KT. Okay. It is equal to 80. You will remember this equation now. Done, guys. Yes or no? Please tell me.
Yes, sir.
Okay. So see, this is very important, very, very, very important, this particular equation. If you remember this equation, then it will be very easier. It will be very easy to remember the odd equation for the first order also. Okay. Now you will write a topic, graph between rate and concentration. Okay, so we will be doing this in the next class. But first of all, write this down. The topic, graph between rate and concentration. Chali. I'm giving you guys some time. You can revise the solution chapter, okay? And then we'll start the test in a while. Okay. You can start the test, okay? You can start the test. But I need all your answers in 30 minutes. Please read the instructions. That is why I have shared the paper earlier. Okay, read these instructions now. Okay. Okay. Yeah. So Mariam was not there on Monday. That is why she's not. Okay. Is she also not in the group? Let me see. Oh, you're not in the group. I will add you, Mariam. Mariam, can you give this test some other day? Yes, Mariam. Okay. Will Friday be fine? Tell me, Friday will be fine? No. Tell me a day then. Which day will be fine for the test of solution chapter? Next Tuesday. Okay then. Okay, fine. But you will remind me, okay, Mariam? आप next Monday हमें remind कीजिएगा that I have to take, है ना? अगर हमें याद रहा तो ठीक है. But I have this very bad habit of forgetting things. Okay, fine. You can leave then, Mariam. You can leave now. Thank you. Others, I hope you have started the test. If you have any doubt, don't message me. Speak out. Okay. जोर से बोल दीजिएगा. One thing I want to tell you guys regarding the fifth question, please look at the fifth question, all of you. Predict the state of the solute in the solution in following situations. When I is found to be more than 1 and when I is found to be less than 1. In this question, you have to tell whether the solute is associated or dissociated. That is it. Okay. So when it is talking about the state of solute, it is asking whether it will be associated form mein hoga, or it will be in dissociated form. That is it from me. Now you can do the rest of the questions also. Now you can see that also one more thing. There are two Salim which are in the meeting right now. And in the bracket, I have written message here. Salim in the bracket message here. So if you want to ask any doubt from via message, you can message me on that account, I would say. Okay, that account. Chalo, thank you. Fatima, I have received your answer sheet. Okay. So if you want, you may leave the class. Okay, Fatima.
Thank you, sir.
Okay. Bye. Thank you. Assalamualaikum. Wafia, I have received yours also. So if you want, you can leave the class. Yeah. Okay. Thank you. Bye bye. Take care.
Thank you, sir.
Sir, I sent the PDF.
Ahmed, I have received yours also. Okay.
Thank you, sir.
Thank you. Bye bye. Sarah, I have received yours also. Okay. If you want, you can leave the class.
Okay, sir.
Bye. Thank you.
Okay, so time's up. Please make the PDF and send it to me.